Okay, good morning, welcome back. Happy Wednesday. Today is day 2 of 3 on operations on algebraic fractions. We got more fractions coming up on Friday. On Monday, we're going to solve equations that include fractions. And then Wednesday, 1 week from today, is our 5th and final quest, only on these 4 sections of fractions. Any questions on the calendar? Okay, then let's jump in here on 233. In this lesson, we continue our work with algebraic fractions to include adding them and subtracting them. So I'll remind you what we did last time. Given a single algebraic fraction, we learned techniques for reducing that fraction. The basic technique was factor everything first and then cancel carbon copies. And then we also had that flippy pattern, right? A minus B over B minus A cancels, but you put a -1 in the front. So that's what we did for simplifying a single fraction. And then we talked about how to multiply fractions. Again, factor everything, cross off carbon copies, and then multiply straight across. And then we talked about dividing fractions. And the technique for dividing was to turn it into multiplication. Copy the first fraction, division became multiplication, flip the second fraction, and then proceed as before. All right, so then harder than multiplying and dividing is adding and subtracting. So that's why we're doing this on day 2. So let's jump in. Here's how we add 2 fractions that have the same denominator. 2/3 plus 5/3. Everybody agree that's 7/3? And we're really happy because it's the same denominator, and so we get to just add straight across the top. I've included this step in the middle, which you would probably never write, but I just want to be clear, that's what we're doing. We are combining 2 separate fractions into a single fraction. You copied the numerators with the plus sign in between, and you copied both denominators a single time, right? It doesn't become 6 in the bottom or 9 in the bottom. You just copy that like denominator once. So let's try over here, where we are subtracting these 2 fractions. It's the same idea. What do you observe about the 2 denominators? They're the same, which is really, really nice, right? That means we don't have to do anything to the denominators. So let's go ahead and write equals here. Give yourself 1 copy of the denominator. And we are going to not combine terms yet. We are just going to write these 2 fractions as a single fraction. So I see a 9x squared minus x in the first numerator. What's the next symbol I'm going to write? Which one? It's minus. Is this minus right here is going right there. Minus. And then you are subtracting the other numerator. 3x squared minus 9x. Everybody see it? Okay, if we continue on this guy in its current form, we're going to get the wrong answer, which is fairly discouraging because I have faithfully copied everything that's up there, right? I didn't make any mistakes. The numerators are copied. The denominator, you just got a single one of those, and I put a subtraction sign in the middle. But here's the mistake that I made. This 9x squared minus x was one thing, right? And I know it is one thing because it is above a fraction line. Same deal with 3x squared minus 9x. And this subtraction is saying you take the first bag of stuff, that first numerator, and you subtract the entire other bag of stuff. We're supposed to be subtracting the entire second bag, but I didn't do that. The only thing I'm subtracting here is 3x squared, but I'm not subtracting this minus 9x. So to make sure that we keep those things in bags, we put parentheses. So this is my strong recommendation, is that for every time when you add or subtract 2 fractions and make them a single fraction, you put parentheses. They were in a bag before, put them in another bag. Okay, and so now the next step is to get rid of those parentheses. The first parentheses are irrelevant, so I'll just copy without making any changes. But what happens in the second parentheses? There's a minus sign outside of that second parentheses. So what does that do to these 2 things? Distribute that minus sign. And it changes both of the signs in here. So it is minus 3x squared and then plus 9x. Still divided by the 3x plus 4. Okay, now we're in a good position to combine like terms. I see a 9x squared minus 3x squared, that's 6x squared. Minus x plus 9x is plus 8x, all divided by 3x plus 4. Okay, here is a new single fraction. It's our answer. It's the right answer. Still, we have work to do. Our job is to simplify our final answers for every fraction problem. And so now we're ready to do the technique from last class. Can I cancel the, for example, the 8 and the 4? Or maybe one of these x's on top with the x on the bottom? And the answer is no. In its current form, this is all additions. Can't cancel when it's additions. You can only cancel when it's multiplications. And so we need to turn these things into multiplications by factoring. The techniques are always greatest common factor, difference of two squares, box, in that order. What is the greatest common factor upstairs? 2 is good. What else? X. Got to get both of them outside. And so I'll pull that 2x outside. What do I have first? 3x, and then plus 4. And then the bottom, there isn't anything to factor, so we just copy. And now, is there anything we can cancel from top and bottom? There is. That 3x plus 4 is a carbon copy. Makes you feel better. Our parentheses around on the one on the bottom. It doesn't change anything, and now it looks exactly like the one on top. And so you cross them off, and you get 2x divided by 1, or just 2x. So that's our final simplified answer. Okay, next up is how do we deal with fractions that have different denominators? So let's take a look at part A here. 9 over 28 minus 3 over 40 minus 1 over 42. In fact, I want to do this one from scratch. So can you go 2 pages away? 235, that's where I want us to put this one. There's room right here below the answer key, although I need one of you to tell me the original problem. Thank you. Okay, so go ahead and copy that right there. We'll have room to put this one below the answer key. Okay, so this one is not as nice as the first one we did because this one has unlike denominators. So the first task is to figure out what the lowest common denominator is. Now, oftentimes, like when you're first learning how to add and subtract fractions, you'll be given problems which are easier to figure out. I don't know, something like 7 over 6. Like you're just supposed to look at it and have a miracle to figure out what the lowest common denominator is. So you could do 8 times 6, which is 48, but you can do better. What's smaller than 48 that both go into? 24. And so it's just, like I said, it's just a miracle. Like you just look at it and you kind of play with the numbers in your head and you figure out, oh, 24 is the lowest common denominator. But good luck doing that on the problem we have. We're looking for the smallest number that 28 and 40 and 42 all go into. I can't do it, but there is a procedure. And so I'm going to show you the procedure, and this procedure is going to help us when we do the same kinds of problems, but with x's floating around. So here is the procedure. We are going to make 3 big fraction lines. And I'm separating, I'm just going to like rewrite those fractions up above, but in a slightly different form. Should be 2 minuses here. All right, so just copying the 2 minuses that we had originally. And I am also going to copy the numerators just like they are. But we're going to change the denominators. We're just going to rewrite them, not actually changing them. Okay, we are going to factor those denominators as far as possible. For example, 28 is 4 times 7, yes? But we can factor 4 farther down because 4 is really 2 times 2. So instead of 28, we are going to write 2 times 2 times 7. You agree? That's the same as 28? Yes, that's the same as 28. Yes, good. 2, 2, and 7 cannot be factored any further. What's the word we use to describe numbers that have no factors other than 1 and themselves? Prime. So the goal here is to factor all the way down to primes. Okay, let's try 40. All right, give me the smallest prime that goes into 40. 2 goes in. So right now in my mind, it's 2 times 20. So now I'm just thinking about 20. What goes into 20? 2 again. So I'll put another 2 there. And now I'm down to a 10. What goes into 10? 2 and 5. So you guys agree that is still equal to 40? This procedure here, breaking down the numbers into their prime factors, it's not hard, but frankly, it's also not one that I need you to be able to do. Like, this is leading to someplace with variables. This is not the end goal. Okay, and then 42, I'll write it maybe in a different way. 42. I think these things are called like a factor tree. 42, for example, is 6 times 7. 7 is prime, so we stop there. 6 is really 2 times 3, and those are both primes. Does that look familiar? So 2 times 3 times 7 is what we can put down here. So however you get there, we should get down to primes. Okay, the goal is to make these denominators the same. Now that we have revealed what they are at their hearts in terms of primes, it's going to be easy to make them the same. All we're going to do is fill in what's missing. And I've got a lot of blank space here in the bottoms to fill in what's missing. So here we go. I'm not going to look at all 3 fractions at one time. I'm just going to do them 2 at a time. Let's look at the first 2. What does this first guy need that the second denominator has? What is this first one missing from the second denominator? It needs a what? What does this one need? This one needs a 5 and a 2. Would you guys agree? That's what this one is missing from the second denominator. But I can't go around willy-nilly multiplying a denominator by 2 and 5. I have changed the value of this fraction. It used to be 9 over 28. It's not anymore. So what I do is I pay for it by, at that same moment, multiplying the top by exactly the same thing. Because you are allowed to multiply top and bottom by the same number, and it doesn't change the value of the fraction. Yes, Megan? Yes. Yes. We're going to be the same number. This first denominator is good now, but let's focus on the second denominator and try to make it the same as the first one. Yeah, so this guy is missing a 7. Agree? That's what the second one is missing. And so right away, if you multiply the bottom of a fraction by 7, you multiply the top by 7 as well. And looking at those first 2 denominators, the numbers are in a different order, but it's exactly the same set of numbers, isn't it? There's 3 2s, there's a 5, and there's a 7. So those 2 denominators are the same. We have found a lowest common denominator for the first 2 fractions. But now we have to expand our horizons and go to the last fraction. Let's just focus on the last 2 fractions here. What is this middle one missing that the last one has? A 3, yes? So we're going to give this one here a 3 times 3, top and bottom, same moment. Okay, but now we've sort of lost track of the first fraction. The first fraction was the same, had the same denominator, so we better give that one the same 3 as before. And then the last piece of this puzzle is to figure out what the last one is missing from the middle one. What does the last one need that the middle one has? It's got a couple of 2s and also the 5. This idea is not a hard one. It just requires careful analysis. And if you look at the 3 denominators, you will find they each have 6 factors, and it's exactly the same 6 factors. Different order, but that's okay. They each have 3 2s, a 3, a 5, and a 7. Go ahead and confirm that one at a time. They have 3 2s, a 3, a 5, and a 7. Yeah? And so that means that these denominators are all equal. We have found our lowest common denominator. Somebody help us out and multiply that on the calculator. 2 times 2 times 2 times 3 times 5 times 7. Any order of any of these three denominators, and that will be our lowest common denominator. Okay, equals. All right, who's got this? In the meantime, we'll go ahead and multiply the top as well. Let's see, 9 times 3 is 27 times 10. That's a 270 up there over whatever we get for the denominator. Minus 3 times 7 is 21 times 3. That's 63 over. And the last one is 20. Okay, who's got our denominator? 840. Let me ask you a question. Could I reduce here? Like, aren't these both divisible by 10 and maybe even more, actually? Do I want to reduce there? No, we did hard work to make these denominators the same. If you reduce, you're going to make them not the same. In fact, if you reduce as far as possible, you will just go all the way back to the original denominators that we had. We don't want that. Okay, so let's put these together into a single fraction. They have a lowest common denominator, so I copy it one time. And then we'll copy the numerators, 270 minus 63 minus 20. I'm going to follow my advice from before, where at this step we put a bag around each of the different numerators, although in this case it makes no difference. Okay, and so I think we're ready for our final answer here. Can somebody help me out? 250, 187? 187 over 840. In theory, we should just double check that there are no common factors in 187 and 840. We should simplify it if we can. Turns out we can't. So we're done with this one. Any questions on that one?
So when you make the three, does it matter if you, like, when you're trying to get all the,
Good question. So the ultimate goal is to get the three denominators the same. You can treat them, you can grab them in any order you want. Just figure out what's missing and eventually make them all the same. Okay, so let's go back to where we were. No, not there. So I think, yeah, we go. 234, just one page back. We're going right here towards the middle. And we are going to tackle this problem right here. My goodness, that is frightening. 234, just one page back. Right there. Okay, so what do I have here? I don't know, it's confusing. I got a plus sign there and I've got a minus sign there. So I guess that means I have three fractions, right? Just three fractions being added and subtracted. Okay, what do we notice about the denominators? Same or different? Different. Well, that's too bad because now we have all the work to do that we just did with those three fractions in different denominators. So our goal is to make these denominators the same. Okay, so first of all, I have copied that thing in its entirety right over here. It's exactly the same. And then I have copied this, oopsies, I copied this thing right here, but notice that I've put some blank space. I'm going to fill in some stuff in that blank space. I need to use that blank space to make my denominators equal. And so it's kind of trivial, but I think it's an important step to set yourself up with space to fill in. This guy right here has been copied right here, but with some blank space, okay? But there's one change in the last fraction. What's different in the last fraction from here all the way over to here? I factored it. Top or bottom? Bottom only, and care about the top. Maybe the top factors, but don't waste your time. It's only about the denominators. This is the step where we took in the numerical example we just did, where we took those denominators and factored them. Instead of 28, we wrote 2 times 2 times 7, factored as far as possible. So instead of this 3y squared minus 11y minus 20, we factored as far as possible. I've hidden the details here. But the factoring techniques have always been greatest common factor, difference of two squares, or in this case, the box. And that's what you do, okay? And there isn't anything to do in the first two denominators. They're factored as far as possible. Okay, so now our goal is to fill in what's missing. So take a look at the first fraction and compare it to the second fraction. When we look at this denominator, there is currently a y minus 5. We are trying to turn it into something that looks like the second denominator, or I guess I should say we're trying to turn them into something that's exactly the same as each other. It possibly is tempting to say, oh, if I have a y and I want to make a 3y, I add 2y. Well, I guess, but adding 2y is not something you're allowed to do willy-nilly in a fraction, and there's no way to pay for it. There's no way to balance the scales. You cannot just add 2y. The only thing we can do is multiply. Only thing we can do is multiply. So the goal is to make these things the same as each other. And in this case, we are going to multiply by 3y plus 4, the entire other denominator, just like it is. But if I multiply in the bottom by 3y plus 4, I must immediately multiply the top by 3y plus 4, which also means I need to put parentheses around that 3y plus 2. That was one bag of stuff. Give it a bag. And then we look at the second denominator and we say, how can we turn it into the first one? What is the second one missing that the first one has? There's a y minus 5. And so we put lots of parentheses, y minus 5 on the bottom, but right away, y minus 5 on the top. I'll put parentheses around the 4 as well. So I said this a moment ago, but I'll say it again. You cannot add. You cannot add. The only thing you can do with the fraction is multiply top and bottom by the same thing. Okay, that's something we believe. Like, I don't want you to just believe it because I'm saying it. Like, I need you to understand like why that is true so that you don't fall into the trap of trying to add. For example, suppose that I had, I don't know, 2/7. And I decided for some reason that I wanted to multiply top and bottom by 3. This is what I'm saying we're allowed to do. What do we get? So 2/7 was what we started with. 6 over 21. Is that equal to 2/7? If you reduce that, you get 2/7. You bet. This is something you're allowed to do. Multiply top and bottom by the same thing. But suppose that I had, I don't know, the same 2/7, and I decide, hey, why don't I add 3? Add 3 to the top and the bottom. Upstairs is a 5, downstairs is a 10. I guess that's a half. Is that the same as the 2/7 we started with? No, we have changed the value of the fraction. You can't do that. We're trying to keep the fraction the same. So multiplying top and bottom by the same number is all you can do. Not add, not subtract. All right. Okay, first two denominators, they are exactly the same as each other. That's a good thing. Now we bring the third denominator into the fold, and we compare the third denominator to the second. And what happy news do we see? That it's already the same. Might not be. We got lucky here. Maybe we'd have to, you know, like multiply by more things to make them the same, but they are already the same. Which means that I'm ready to add these things together and make a single fraction. So let's do that. Equals. Okay, big old fraction here. Let's copy the denominator before we forget it. Y minus 5, 3y plus 4. Other order is okay, but it's just one copy of that denominator. And then I'm just going to carefully copy all of the stuff in the numerators as they are. 3y plus 2 in parentheses times 3y plus 4. That's the first numerator. What's the next symbol I'm writing? It's the plus sign. And then we'll copy the next denominator with all the glorious parentheses, y minus 5. And then the next symbol is that minus sign, the subtract. And then 7y squared plus 24y plus 28. I have made a fatal error in this problem. We'll get the wrong answer if we don't fix it. It's parentheses. I should have 3 bags of stuff for my 3 numerators. The first numerator, it's already in a bag. It's a couple of bags. It's fine. Second numerator has bags. The third numerator does not have bags. I'm supposed to subtract the entire thing. Well, I've subtracted the 7y squared, but I'm adding 24y. I wasn't supposed to do that. I was supposed to subtract all of that stuff in the bag. It needs a bag. I said it earlier, but when we go from several fractions to a single one with addition and multiplication, put bags around all those numerators. Okay, so the rest of this isn't hard. Like, we finished the hard part. But there's still work to do here. Our job is to clean this thing up. This is not a good final answer. We're going to distribute through all of those parentheses to get rid of them, and then we're going to combine like terms. Fair? Okay. So equals, distributing in the first one, it's foil or lobster claw or box or monkey face, whatever you want to call it. We're just going to write the answer here. 3y times 3y, that's 9y squared. 3y times 4, that's a plus 12y. I'm doing the inners here, 2 times 3y, that's plus 6y. And then finally the last is plus 8. And next we're distributing the 4. So 4 going through there is a plus 4y minus 20. And now I'm distributing the negative sign. So what do I write? Minus 24y minus 28. Really easy to miss that negative distributing. Divided by, copy the denominator. You could distribute here on the bottom, but I'm going to say you should not distribute on the bottom. So the reason we distribute on top is that some of the terms are going to combine. Right now we're about to combine terms, and it's going to get smaller, which is a good thing. But if you distribute on the bottom, there's no combining. It's just going to get bigger. Additionally, in the last step of this problem, once we've got this fraction reduced as far as possible, we want to simplify it. And that means factoring top and bottom and hoping to find common factors, right? Things that we can cancel, carbon copies. Well, the bottom's already factored. So don't unfactor it. It just gives you more work to do later. Okay, looking for like terms. I've got 9y squared there, minus 7y squared there. That's a 2y squared. Next up are the y terms. 12y plus 6y is 18y, plus another 4y, that's 22y. Any more? Minus 24y. I think it's negative 2y at the end of the day. Yeah, I think that's okay. And then finally, the constant terms. 8 minus 20 is negative 12. Minus 28 is negative 40. Okay, so this answer is pretty good, but it's not simplified as far as possible. So we need to see if there's anything we can cancel. And we saw last class that the idea is to turn everything into multiplication to see if we can cancel. So downstairs is already factored. That's why I said don't distribute. We leave it just like that. We want the top to look like the bottom with parentheses so that maybe we can cancel. So greatest common factor is always first. What is the greatest common factor upstairs? 2. So we pull it out and get a single set of parentheses. Everything else copied. Okay, what's left when I pull out that 2? Let's see, y squared minus y minus 20. And then we have to see if we can factor further the thing in the big parentheses on top. We've done the greatest common factor. Is the top a difference of 2 squares in the parentheses? Nope, it's 3 terms. So what's the other technique for factoring? It's the box. So we'll tell you that the box works here. And we're not going to do the details. Take your time when you do them on your own in the activity. But let's just put the answer here. So using the box, we will get y plus 4, y minus 5. Notice that I've copied the 2. You got to make sure you copy the 2 in the front. Okay, and do we see anything that will cancel on top and bottom? Y minus 5. It's carbon copy, so we get rid of it. Is this the thing where we put the -1 in? No, right? Just because they're both minus doesn't mean it's the -1 thing. The -1 thing would be if they were in the reverse order. So we cross them off and we write our final answer, 2y plus 4 over 3y plus 4. You can put parentheses around the bottom. You don't need to. Can you cancel the 4s? Can you cancel the 2 on top with the 4 on the bottom? Nope. We are as simplified as possible. Whew. Not so easy, huh? I think I need some Gatorade after that. That was tough. All right. Last example, and then you'll jump into the activity. Just the highlights for this one. So here's the original problem. I see 2 fractions being subtracted. How can we factor this one here? Greatest common factor, what is it? X. So you pull an X out and you get X minus 1. Okay, so those denominators are equal and the second one is factored. Let's take a look at this guy. Just in the first parentheses. Greatest common factor is 1. That's not helpful. It's not a difference of 2 squares. So we use a box. Again, we're going to hide the details. You'll have to take my word for it that these 2 things are the same. That's what you get from the box. Also notice that this X minus 1 that was already sitting there is copied out there. Okay? So my denominators are all equal, but now they're written in the much better factored form. And let's start filling into the blanks. Let's do this here. Okay, looking at the, let's go with the second denominator first. What does the second denominator need that the first denominator has? Just X. See it right in the front? So we multiply right here by X. And therefore we also multiply the top by X. And therefore we bring parentheses in. So the second denominator has everything it needs. Let's see what the first denominator is missing. So what does that first denominator want from the second denominator? Yeah, what? There's an X plus 5. So I'm going to give it X plus 5, top and bottom. I'll put a bag around the 4 even though it's not necessary. And then another X minus 1. That's the whole point of this example. We're not going to do any more of this example. But the idea here is you say, oh, look, it's got an X minus 1, and it needed an X minus 1, so we're fine. But it needed another X minus 1, which it doesn't have. These denominators are not the same yet. This one over here has X minus 1 twice. This one needs X minus 1 twice. And so if you look carefully at our 2 denominators now, you'll see they each have 4 factors in different order, but they're exactly the same. There's an X plus 5, and there's 2 copies of X minus 1. So we have to be prepared to deal with repeated factors. You just throw them in until they both have exactly the same number of those common factors. Okay, so let's jump into the activity, which starts on the next page. I will walk around.